We are a species of explorers, believers.
We choose to go to the moon in this decade and do the other thing, not because they are easy, but because they are hard.
We are willing to do the hard things, to overcome the many challenges. This is what brings out the best in us.
We go for a mission to the moon.
Our path has led to success and to bitter losses.
We come together today to mourn the loss of 7 brave Americans.
Yet, even when faced with tragedy and setbacks, we persevere. We keep striving. We keep believing. From space, we see our planet as a whole. We see the challenges facing it, and we face those challenges together. We will not give up. We challenge convention. We refuse to accept the status quo. The time at hand is hard, but we will persevere. We can still draw hope from the moon and the stars, from space, from exploration. There is a new day beyond the challenges we face now.
Curiosity, insight, spirit, opportunity. If you think about it, all of these names of past Mars rovers are qualities we possess as humans.
10, 9, we have ignition sequence start.
But if rovers are to be the qualities of us as a race, we missed the most important thing.
3, 2,
perseverance.
launch commit, liftoff. We have liftoff.
We are a species of explorers. We will meet many obstacles on our way to Mars. But as humans, will not give up. We will always persevere.
To the world, but to the world to put instruments on this rover. And so Justin and I and a team of scientists and engineers put this proposal together in 2013. And there was something like just shy of 50 proposals submitted to NASA from around the world for cameras and spectrometers and other kinds of instruments for the rover. And so, we did our best to pitch our case for these great zoom lenses, wide angle to narrow telephoto, and then we just waited. And in mid 2014, they picked us, and we were super happy and super excited. And then it was like, oh my gosh, we actually have to do this now. And then the normal process is we spent a couple of years of just reviewing the design and convincing skeptical engineers and managers at a lot of whom are at Justin's home institution, JPL, that we could build this, that we could do it. And our colleagues from Malin Space Science Systems, who are our prime contractor, they actually built the cameras for us. So they had to be an important part of this with us. And so the cameras didn't exist for a couple of years. They were just PowerPoint cameras. They were just slides and presentations, meeting after meeting. How many meetings, Justin? Hundreds of meetings, right? And so
hundreds, literally.
Yeah, literally hundreds. And so it took a couple of years to get through these reviews. And then sort of in like 2016, we passed what's called our critical design review, which is like, yay, verily, you may now go build the cameras, blessed by the committee of experts. And that's when we started building them, primarily in San Diego at Malin Space Science Systems, but parts coming from all around the country, all around the world. And we tested them in 2017, 2018, including here on campus, on the ASU campus and ISTB4. We did some of that testing and did the final calibration then in in San Diego in 2018 and 2019, delivered the cameras. I can show you a model in a few minutes, but delivered the cameras to JPL, and Justin and his colleagues then mount them up onto the rover in 2019. And then they went through a whole bunch of testing with the rover, including putting the whole rover in a thermal vacuum chamber and simulating the Martian environment. And then the whole rover gets shipped to the Cape in early 2020, or late 2019, early 2020. And now it's sitting on top of that beautiful rocket waiting for a ride. So it's been a great ride to get to this ride.
Yeah. Yeah, so absolutely, I mean, years of work, you know, I mean, I think it's obviously represented many, you know, people involved in this over the years, and a lot of effort. And so I can imagine that, you know, it must be really a little bit nerve-wracking to sort of sit and watch that little rover sitting at the top of that big rocket. And so Justin, did you want to add anything in terms of your journey through the years with this particular mission team?
No, I think, well, Jim had a great summary. I think that one of the interesting things about these projects is really how long they take to develop. So as Jim mentioned, we first started working on the proposal in 2013.
Yeah,
that sound about right. And
yep.
You know, the different phases that you go through. And in this particular case, because Mastcam Z is built on previous missions, it even goes farther back, the development. And Jim and I have been working together now for over 20 years, developing cameras and slowly improving on the technology. And so just to see that progression go through and get to this point, it's very exciting.
Right. No, this is great. So I wanted to actually ask some of the other team folks who are here as well to tell me a little bit about how you're feeling this morning. Kristen, did you want to add anything?
I'm feeling pretty excited. Like everything's basically, it's outside of our control now, and it's just have the folks at the Cape do their jobs, and yeah, get off this planet.
Let's get off this planet.
Yeah.
Let's
go to Mars.
Light the candle, right?
Yes.
Yeah.
Yes.
What about Ernest?
Oh yeah, this is the second mission where I've worked sort of from the beginning of the instrument selection through design. So I came on in 2016, right before the critical design review, and we've been so busy. And actually, probably about 15 minutes ago, it was kind of like, oh, okay, we're really going to do this now. This thing's going to launch, and we're going to have some excitement. In about 6 months, it's going to get super exciting when we hit the surface and start operations.
All right.
And, just to break in, all 3 cryogenic tanks on the rocket have been topped off to flight level, so we are fully loaded with fuel,
nice.
And the weather is still a go, so it's all looking good. Yeah.
It's looking like a beautiful morning on the Cape over there.
Yeah.
Mm-hmm. And
it does look really nice there.
Yeah, it looks beautiful. So I want to go to Alyssa. How are you feeling this morning, Alyssa?
I feel very confident in all the people that got it to the launch pad, and I think it's going to be a really exciting thing to watch.
And how long have you been involved with the team?
I'm pretty new to the team. I started in May, so it was always like, "Ooh, we're launching" from the beginning. So I think it really sunk in a couple days ago. It's like 2 days. Oh my God, we're actually launching.
And Samantha, what about you?
Yeah, I think I second everybody's sentiment of excitement. I joined about 2.5 years ago as the cameras were being finished. So it's pretty excited to see them on that rocket. Imagine them on that rocket. I'm also part of the Curiosity team, but I joined right before landing. So I have not experienced the launch portion of a mission I'm on yet. So this is a new piece for me.
Yeah, so definitely a little bit nerve-wracking. So Corinne, how about you?
Yeah, I'm very confident in everyone in the mission control for launch. they're probably a lot more nervous than I am. But yeah, I'm just sending warm energy to them.
So
and yeah, that's pretty much it.
Yeah, no, this is really wonderful. So actually, I was thinking, why don't we actually talk a little bit about where we're going on Mars and why we're going there. So actually, I think we have a flyover video of the site, and if we can try to cue that and
so
show some of that, maybe Jim can talk a little bit about that.
Sure, or if Corinne has the beautiful background there that has our landing site in false color.
Ooh,
the spectacular
yes, of course.
delta in
Indeed.
In Jezero Crater, right? But sure, if you want to try to roll that that video, that'd be great. Whoever's going to run that. We have some colleagues on our team. It's an international team, and some of our colleagues are from the group in Germany that does a lot of sort of stereo imaging work. They run the high-resolution stereo camera on the European Space Agency's Mars Express orbiter. And so I got this from Ralph Yaman, one of our colleagues on the team. And this is a flyover in 3D of Jezero Crater, of our landing site. And we chose this landing site. It was a fierce competition in the Mars community. It took more than 3 years to decide. A series of international meetings open to everybody, and different sites were pitched, like 50 different sites initially. And here we're zooming in on the winner, and that orange ellipse there is our landing ellipse, the highest probability area that we think we can land in on February 18th of next year. And on the left side of that ellipse now, the western side of the crater, you can see that geologic feature, that delta, that riverbed delta coming out of that channel and the wall of the crater. That's what's drawn us there. That feature tells us this was a lake, this was a crater lake filled with water 3-4 billion years ago. It was a habitable environment by the standards that we judge habitability. And so on Earth, those kinds of places are great environments to preserve evidence of habitability and even life. And so, you know, we don't know if Mars was inhabited, but we know that it was habitable. And this is something that's come from the orbiters and other rovers and landers over the past few decades. And so that NASA's whole Mars exploration program and contributions from the Europeans and others have guided us to this really special place. I know, Corinne, I don't know if you want to say anything about the work that's being done on the whole team, because you're part of that, of analyzing in more detail the places that we could go there. Maybe you could say a few words about that. No?
Corinne?
Oh, sorry.
Yeah.
I'm having internet connection issues, so just making sure I'm up to date. Could you repeat the question?
I was just wondering if you'd say a few words, since you've been participating in the landing site strategic process. Maybe just a few words about going down there.
Yeah, just a few words. Yeah, so a lot of the science team is separated into different groups, focusing on whether like the delta fan, which you can see here, and some over on the crater rim, which is over here. There's about 5 different groups for 5 different areas of the of Jezero Crater, of our landing site. And yeah, so we're already planning on getting waypoints and landmarks where to drive the rover from where we can see with orbital data for now.
Cool. Yeah, so we don't know, Minnie, we don't know where we'll land in that orange ellipse. Statistically, it'll be in the middle, off the delta, and then we'll drive to the delta, but we just don't know. And so a number of folks on our team and the broader science team overall are just sort of piece by piece of that ellipse, looking at it and saying, okay, what if we land here? What if we land here? What if we land here? And then when we figure out, we open our eyes on February 18th of next year and figure out where we actually are, then we'll have hopefully a plan.
Yeah, and I think the wonderful thing about that site and the reason why it was chosen is because no matter where you were going to land in that landing ellipse, there's going to be a diversity of rock types and rock samples that could be collected, and it's going to really give us a view into the history of Mars, particularly of what it was like early on when was lots of potentially water lakes and riverine systems there. And so yeah, it'll be super exciting. I mean, I think some of the questions that certainly that come to mind as far as how are we going to pick those samples, and what's going to really help us. Maybe we can hear a little bit about some of the other instruments that I know that the team that's assembled here. We are part of the Mastcam Z imaging system, which are the eyes of the rover. But there are a number of other instruments that are on the rover as well. And so maybe somebody wants to talk about some of the other instruments that are going to help us select the different kinds of samples from this particular mission, or during the course of the mission. So maybe, I don't know, does Alyssa want to say anything about some of the other instruments maybe?
Well, there's 7 instruments on board. I don't know a ton about all of them, but there's some really cool stuff like MOXIE, which is, it's supposed to take carbon dioxide from the air and create oxygen. So hopefully we'll be able to use that in future missions.
Yeah, human exploration is going to be supported that way, right? I mean, so the humans are going to need oxygen when they get there. So this is just sort of a test. So that's fantastic, right?
Yeah, and there's so many instruments on the arm and all sorts of places. I think maybe someone else is a better person.
Absolutely. Did Samantha want to say something about maybe 1 or 2 other instruments that are interesting for her?
Sure. So one of the other instruments on board is called SuperCam. So this is the instrument that uses a laser. Actually, SuperCam will use a couple different lasers to understand the overall chemistry composition of the rocks that we analyze. So that'll be used in conjunction with Mastcam Z. And we also have an instrument called RIMFAX, which is pretty exciting because it's a ground penetrating radar. So this will be the first of its kind on Mars, and we'll get to see how the layers look beneath the surface of the rover. What else? We also have a couple other instruments that will help us analyze the cores, the drill cores that we are actually caching to eventually bring back to Earth.
How big are those drill cores actually, and how many are there? Do we know at this point that we're going to be collecting all of them as well, and all of that? But if you could, just say a little bit about some of that too, if you would.
Sure. I think Perseverance has up to 40 different sample tubes that you can take throughout the whole mission. And then Justin might know more, but I think they're only a few inches long by maybe an inch.
Half an inch, yeah, exactly.
You know what I've been using? I've been saying that they're the size of a whiteboard marker or a cigar tube. Either one of those, it's about the size that they are. Yeah.
There you go.
So that's great. And
you should ask Justin about the really cool helicopter that's on the rover.
Yes, I mean
he's on that team as well.
Yeah, let's hear about the helicopter actually, because this is a first for any kind of mission on any planetary body, of course. So Justin, can you say a little bit about that?
Yeah, so it is a first. It's a it's called a coaxial helicopter. So it has 2 blades that sort of spin in opposite directions, and it carries 2 instruments, 2 cameras. One of them is a low resolution camera that looks straight down, and it is black and white, and it is used for navigation. So it just looks at the ground as it passes from underneath it, and then uses those images to calculate how fast it's moving and track where it is. The other camera is more interesting. It's a 13 megapixel color camera. And it is actually, not only is it very much like a cell phone camera, it is a cell phone camera. We had such tight weight requirements that it had to be so light that the only camera that we could find that met those requirements was a cell phone camera. So the good news is that there are a lot of cell phone cameras out there, and so we were able to work with some of our industry partners to procure some cell phone cameras. Turns out they're harder to purchase than you'd think. You could think you could just go buy one, but mostly the manufacturers won't talk to you unless you want to buy like 1 million. So we did not need to buy 1 million, so we had to work with some of our industry partners to get some. So the camera itself is sort of a fisheye camera. It looks out kind of towards the horizon and then all the way to underneath the rover, and takes really great color pictures, very much like a decent cell phone camera that works pretty well outdoors. So we're really excited about that capability, and the first one, hopefully one of the first pictures we'll take is when the helicopter does its first little test flight. It'll go hover off the ground and we'll take a picture of the rover out kind of on the horizon. So very exciting, and we're going to be taking pictures from multiple positions and generating stereo data like we do with Mastcam Z. Very similar kind of technology, but in this case, the camera itself, instead of 2 cameras, we just have 1 camera that moves to 2 different places. So the helicopter is really an exciting. It's a real groundbreaking, pioneering, technology demonstration. And on the Mastcam Z team, we're equally excited about it because we are going to take pictures and video of the helicopter flying.
Movies, yeah, movies. Yep.
Exactly, wow. Movies. So we're really excited about that.
Yeah, so for the test flights, the idea is that we're going to back the rover off like half a football field to a football field away, because we don't really know how the thing's going to fly, and we don't want it to crash into the rover. It is a test, it is a demo, right? So we back off, which means that to most of the cameras on the rover, it's just a little dot, but we've got these super powerful zoom cameras, right? So we will zoom in and get a really nice stereo movie of the flight, multiple flights of the helicopter. So yeah, we're super excited about that. And I should add that we'll do the processing of that, all those pictures and stuff here in this. That's why we're in this room. Rick, maybe you could do just a quick wide-angle pan around. Those of you who know the ASU campus and know ISTB4, this is the ground floor Mission Operations Center, the fishbowl with the big glass windows as you walk in. And so this set is set up right now. It's a shared facility. We do a lot of the processing and calibration of Curiosity data from the Mastcam instrument. We're getting ready to work with Psyche data. Ernest runs the Psyche data center out of this facility. Some of the folks at ASU who run the LunaMap mission are working in here as well. And this will be our main operations center where Kristen and her downlink team, she's our downlink lead, will do all this great work.
Yeah, we're very excited for this video, and of course all of the other images we're going to get naturally.
Yeah. Maybe you could say something about the website too that we just launched.
Yeah, so we just launched a website. It's the mastcamz.asu.edu. So I believe that's live now.
Is it live now? Not yet. Use your mic.
So it'll be live
not
soon.
Soon.
Okay.
That's fantastic.
Small technical difficulty.
Okay, you can go there for all the technical details of the camera. We have some really awesome images up there of people interacting with the hardware, and that's where we'll have once we receive the images from the rover and process them, we'll be putting up the false color and multispectral images, and in near real time.
Oh, that'll be fantastic, and surely we're looking forward to seeing all that fantastic data.
Sorry, I can't stop monitoring the feed here. So the winds aloft are
we're getting
go.
Close.
Winds aloft are go. Fully fueled. Launch Control Center is ready. I haven't seen anything about the range yet. I don't know if Justin, if you've seen anything about the range, but it's all looking good, and we're getting close, right? We're within 10 minutes or so. I don't know when do you want to switch over to the NASA feed?
Live feed.
You want to do that?
So actually, I think it's approaching 4:40 right now, 4:38. So
Yep.
maybe we'll probably, and the launch is supposed to happen at 4:50 our time. So maybe
Yes.
we'll cut away there in another couple of minutes.
Okay.
And in the meantime, actually, let me just take a couple of quick questions from the Q&A that we've been getting. There's one from Bill McGee who asks, how big is the landing site ellipse?
I say 25 kilometers, 20 kilometers. Is that right, Corinne?
Yes, 20 kilometers.
Yep. Yep.
I'd say
Oh, okay.
28, I think, but yeah, around that.
Between 20 and 30.
Ah.
Which is kind of incredible, right? Because it's, you know, hundreds of millions of miles away, and yet this rocket and the landing system are going to get to this pinpoint little place on this big planet. So
Yeah.
I'm always blown away by that.
So before we cut away, just one quick question that's sort of related to this. What's the vertical scale of the landing site? This is from Bruce Shapiro, who asks, in other words, how high are the geologic features that you expect to encounter when you go to that particular landing site ellipse?
Yeah, so there are obstacles in that landing ellipse that are from a few to a few hundred meters in height, and of course there's the rim of the crater, which goes up many hundreds of meters, which is just outside of the ellipse. But generally, it's been chosen because it's relatively smooth and judged to be safe for landing. And the rover itself has an onboard computer that will be taking pictures as it's going down, matching them to a map that it's got on board, and adjusting its position as it comes down to avoid any of these, you know, the highest of the mesas and other obstacles in there. So, you know, partly why we're not aiming to land right on the delta is because it is pretty rough terrain, although part of the delta is in the landing ellipse, so we might statistically land on it, and that's still being judged to be safe. Anything you want to add to that, Corinne or Sammy or Justin? No? Okay, I think you got it.
The morning.
All right. So should we go to the NASA live feed at this point? I think we're about 10 minutes out.
Yeah, people don't want to see us. That's what they want to see. They want to see the rocket.
They want to see the launch. Yeah.
All right.
Spacecraft customer is incredibly important, so usually we're able to be here working beside them on their equipment and making sure that all of their needs are covered even before they ask for it. It is a challenge, but we're used to meeting unique requirements here at the hangar, and we pride ourselves in our flexibility.
This is just another mission, just with a different set of obstacles that we have to overcome. It might not be, you know, like a broken rocket, but it's got its own challenges.
Our job is to go into the unknown, and this is just another example of the unknown. How to make this job happen when you're doing it largely through a computer screen.
I asked the team a couple months ago if they would like to do something to kind of symbolize and mark these challenges that we faced, and they designed something that we called a COVID-19 Perseverance Plate that's now affixed to the port side of the rover. It has a globe representing all of us that face this challenge together, the spacecraft leaving the Earth on its way to Mars, and all of this supported by the now familiar staff and servant of the medical community. And we hope that this mission, in some small way, can inspire them in return. Pretty much everybody that I've talked to that's associated with the mission has said the same thing, which is you could not have come up with a better name than Perseverance.
We have persevered through this. Nobody's given up. We will get this mission done. We will get it done through the pandemic.
I think it's a really important symbol of humanity, hopefully persevering through this great challenging time that we have right now.
We appreciate that team as well as the medical community that really stepped up and helped. And it's ironic, you know, Moo, because the name Perseverance was chosen by a 7th grader who at the time he submitted that name, he didn't know that we would be faced with a global pandemic. So we are glad to have him and his family here along with the student who named the helicopter to watch the launch in person.
Their names are Alexander Mather and Vanessa Rupani, and they are watching from the 5th floor balcony of our engineering building, just a stone's throw away from the countdown clock. Look at that, there they are, looking cool. Alexander Mather, who goes to Lake Braddock Secondary School in Burke, Virginia, submitted the winning essay to name our rover Perseverance.
Yeah, they've got a great view. I've seen it from up there. They've got the VAB in the background, as you can see there. So
cool.
It's such a beautiful setup for this awesome launch. And Veniza, who you can see her, and they're waving. Hey guys, appreciate you. She's a junior at Tuscaloosa County High School in Northport, Alabama. She entered the contest as well and came up with the name Ingenuity for our helicopter that will accompany our rover to Mars. Thank you both for being here. What a neat view that is.
Yes.
All right, folks, with the coast phase coming up, we want to let you know that after the launch, it will be about an hour before Mars Perseverance separates from the second stage. When that happens, the rover will then be on its way to Mars, so hang in there.
Yeah, don't go away, as we will walk you through the flight around the Earth, and we'll talk live with the astronaut Zena Cardman about our human exploration ambitions and NASA's Associate Administrator of Science, Dr. Thomas Zurbuchen.
It's going to be great, folks, so stick around. It's L-6 minutes and 26 seconds now, and time to focus our attention on the launch operation the rest of the way to liftoff. So let's send it back out to Mick Woltman and Joshua Santorin. Gentlemen.
Thank you. I want to let you listen into the remainder of this poll in motion. Let's go to that now.
Range coordinator.
Clear to proceed.
Launch director.
LD is go, and you have permission to launch.
Proceeding with the count. ALC, verify T0 is set for 1150 Zulu.
So 11:50 Zulu. That is 7:50 a.m. Eastern
yes.
time. So that time is correct.
As I'm watching Josh do the calculations on his finger there.
Get my abacus out.
Right.
No. So there's a lot to come ahead. One of the things coming up in just a few seconds.
Minus 5 minutes, 30 seconds.
OS,
NSC.
Go NSC.
Spacecraft on internal power and timer set for T0 of 1150 Zulu.
Roger. OS, start list data capture.
Roger.
Fantastic.
All steps are complete prior to terminal count. LC switch is ready.
Awesome. So things are really starting to pick up here. You're going to hear more and more chatter on those nets there. That call was to say that Perseverance is powered and ready to go, which is a phenomenal call.
Yeah, a couple things happened during that time, right? Is launch conductor, ULA's launch conductor, Scott Barney, polled the whole ULA team. They were all go. We got to hear
the third of our 5 teams.
The third of our 5 teams. We got to hear the end of that where the range was clear to proceed, and ULA's launch director, Bill Cullen, gave the authority to go for launch this morning at 7:50 a.m. Then we got to hear from the JPL spacecraft team that they are
the fourth team,
that they are on internal power and timers are set. They are targeting a liftoff of 7:50 a.m. this morning. So all things are looking good for us, Joshua, this morning. It's so, we talk about being nervous and excited. This is right here where we're nervous and excited.
Yes.
There are a lot of things happening as we get ready to count down to the liftoff this morning. We have about 15 seconds left in this hold before we pick up the count.
Yeah, we're going to listen into that. The 5th team, the one we haven't mentioned yet, is the Department of Energy, who is responsible for the MMRTG, the power source for Perseverance.
3, 2, 1, mark.
Awesome. So this is now the terminal countdown. This is that time when things become more and more automated over the next few minutes, and the energy's building, but the focus is increasing exponentially.
Yeah, as Tori said during his interview, the teams are very disciplined, very focused on what they're doing, the operational sequence of events that they're following. They are making sure everything happens, especially in this T-4 and counting period, because there's a lot of things they have to do. They have to finish topping the vehicle, make sure that all the tanks, first stage, second stage on Centaur, are at flight pressures and full of fuel, ready to go for this morning. They have to make sure the FTS system is armed and ready for personnel safety just in case, so that the range can do that. They have to check the electrical and avionics systems. They have to make sure that the flight computer has all the information it needs to place Mars 2020 into the orbit it has to. So a lot of things going on. Exciting time for the team right now, but again, staying focused and following that procedure they've got.
3 minutes.
As we look ahead to post-liftoff, I want to kind of preview for you what's going to happen, because there's going to be a lot going on. You're not going to hear much from us. You'll actually be hearing from the ULA flight commentator, Jesse Gonzalez. He'll be kind of giving those calls past liftoff that will walk us through maximum dynamic pressure and into SRB separation, and then into fairing separation, booster separation, and then the first main engine ignition of the Centaur,
yes.
RL-10. And so then you'll kind of hear us jump back in and help provide some more context to what's going on. We encourage you to stay with us for the rest of the show, though. There's a ton more content we have to bring you, and we are far from over. I want to emphasize that the countdown to Mars is not done at 0 today. The countdown to Mars ends in February, when Mars 2020 safely delivers Perseverance and Ingenuity to the surface of the red planet. So we're going to let you listen in now and enjoy the last couple minutes of the process of launching a rocket.
One minute 59.
Vehicle internal.
1 minute 55.
Launch sequencer start.
1 minute 50.
Securing Centaur LH2.
Securing Centaur LO2.
So there we heard the fueling is
1
wrapping
minute
up
40.
there.
Yep, fueling is wrapping
Launch
up.
enabled.
Team is gone. Launch enable's
137.
done. Launch conductor sequence is ready to go. They're getting ready to turn the vehicle over to auto
FPS
sequence at T-minus 31 seconds. So that's a big thing that they're getting done here. At T-minus 25 seconds, we will hear the team give their final goes that everything is ready and
1
the
minute
launch
20.
vehicle is ready to lift off and
OCU
perform
armed.
this mission.
SCS count
1
started.
minute 15.
Produce ACS for launch. Roger.
1 minute 10.
Then valves locked.
One minute.
Rock, report range status.
Range green.
That's good to hear, Joshua, right
That means
there.
public safety there is accounted for. The FTS system, there you see on your screen a beautiful shot. The skies look great. There is little wind happening. You'd be able to see more of the venting. If there were wind, the trail of that venting. So we're ready to go.
And actually, that's an
40
important
seconds.
point. The reason we don't see that
Stable at
venting is
step
the
3.
vent valves have been locked up to put flight pressure into the tanks. And as we just heard, they're stable at step 3, which means the tanks are ready to go. And here at about 5 seconds, we will
28
hear
seconds.
the team
ECS reduced for launch.
give their
Roger.
final go.
25 seconds.
Status check. Go Atlas.
Go, Centaur.
Go Mars 2020.
There we go. We are ready to go lift off this morning, Joshua.
Eight, 7, 6, 5,
5.
4. Engine ignition. 2, 1, 0.
Release.
And liftoff. As the countdown to Mars continues, the perseverance of humanity launching the next generation of robotic explorers to the red planet.
And Atlas TU has gone to closed loop control. Coming up on 30 seconds into flight, the RD-180 is throttling down as expected. Engine response looks good. And Mach 1, Atlas 5 is now supersonic. And passing 45 seconds into flight, vehicle is now passing through max Q, maximum dynamic pressure. And passing 1 minute into flight, the RD-180 is throttling back up as expected. Engine response looks good. At this time in flight, the SRB chamber pressures remain nominal. The RD-180 pump speed and fuel injector pressures are responding well to demands on the engine. Standing by for SRB burnout shortly. And we have burnout on all 4 SRBs. Burnout pressure signatures look good. Standing by for SRB jettison shortly. And we have a good indication of SRB jettison of all 4 SRBs. And the vehicle has gone to closed loop guidance. Vehicle body rates are responding nominally at this time. And coming up on 2.5 minutes into flight, the RD-180 is throttled down slightly as expected. Engine response continues to look good. At this time, the vehicle is 50 miles in altitude, 85 miles downrange, traveling at 6,000 miles per hour. And the Centaur reaction control system is now pressurizing to flight levels. And just past 3 minutes into flight, the RD-180 is now throttling to maintain a constant 2.5 G acceleration limit for payload fairing jettison. Engine response and vehicle acceleration look good. And we have good indication of payload fairing jettison and Centaur forward load reactor deck jettison. And the RD-180 is throttling back up to attain a 4.6 G acceleration. Engine response continues to look good. And Centaur has begun the boost phase chill down sequence to thermally condition the RL-10 for operation. Standing by for BECO shortly.
BECO's the call for booster engine.
And we have BECO, booster engine cutoff, standing by for stage separation. And we have good indication of Atlas Centaur separation.
So there you're seeing live footage.
And we have
the
MES
rocket.
1. RL-10 operating parameters look good. Chamber pressures are stable. This will be the first of 2 burns for today's mission. This first burn will be approximately 7 minutes in length.
So Mick, that's pretty exceptional footage there. That's live video. We will see that switch over shortly into an animation that kind of helps let us know what's happening with the rocket. But right there, a beautiful liftoff. Fun to feel that rumble in the building here as we proceed towards orbit and then towards Mars destination.
Yeah, absolutely. It was great watching an on-time liftoff of the Atlas V with that little over 2 million pounds of thrust. Cleared the tower in roughly 5 seconds. Josh, you and I worked the InSight mission, and if you recall, that mission on the West Coast took about 17 seconds to get past tower. So with those 4 solids today, this thing really got out of here and on its way. And it's, as we hear from Jesse, everything's looking nominal, and all vehicle parameters are within the design limits, and we're getting ready to come up on a main engine start for that first burn that Jesse was talking about.
Yeah, so recapping this countdown to Mars, the stations began to be filled up this morning just after midnight. Preparations, fuelings, powering up, all the way through that liftoff that happened. I think, Mick, it wasn't precisely on time. I think you said it was like 10 milliseconds early. So it's pretty much dead on.
Yeah, dead on. This team does a great job. As I said, they're very focused, very disciplined. As Tori also said, courageous. They have done a lot of work to get us to this point today through this pandemic, changed how they did some of their work, made adjustments as needed, a lot of cleaning, a lot of things, a lot of wearing their face masks, doing all kinds of things. And so this is an exciting time, not only for the JPL team in Mars 2020, but everybody that's worked this mission, and for the country and the agency. So this is exciting to see. We still have a long way to go, Joshua, before spacecraft separation.
Yeah, we had a really quiet countdown today, which is phenomenal, that we got off the ground on time. And we are proceeding now that we are in the middle of the first burn. It's tough to make out, but that engine is lit and it's firing. So we are in motion. There you go. There's that animation we talked about.
The telemetry there as we switch to a TDRS compatible data format.
TDRS.
Overall telemetry quality is very good.
The space tracking system. So there you go. This is not an actual video, but this is an animation that's driven by real data. So although we're not actually seeing the engine on screen right now, we can see that the engine is lit, and that is driven by the data that says that the engine is truly lit and we're in this burn.
Yeah, the launch vehicle continues to send telemetry to the launch team via the TDRS network, as you mentioned, and that allows them to continue to watch what's going on and make sure all their sequence of events meet their timeline. We continue on a nominal flight this morning. This first burn, as we heard earlier, will be about 6 minutes. This will get us into that park orbit around Earth, allow us to get on our way, and then get into that approximately 30-minute coast period that we're going to have.
8 minutes into flight, beginning to see the Centaur PU system balance out mass errors, seeing very stable body rates in the Centaur.
So we've mentioned 5 teams at play, and although if you were watching, hopefully you got a chance to see this in person, if not on camera, it's easy to kind of say, oh, it's over, like job done, but all 5 of these teams still very much engaged, still very much focused, because there's a lot of work ahead as we proceed through this first burn, and then a coast phase, like you mentioned, Mick, and then a second burn, and then spacecraft separation and the acquisition of signal from Mars 2020. So a lot more coming up here. Mick, I know for Launch Services Program, you guys manage the launch. So what does that mean? I mean, this is you guys' work in action right now.
By the way, that's the 5th team that we didn't get to mention. We talked about JPL, we talked about DOE, we talked about United States Space Force, and United Launch Alliance. LSP, we are like the brokers to select this launch vehicle and help with manage this mission. So we get our spacecraft customer, the JPL folks, they come to us. They have some certain requirements that they need for this mission. The Launch Services Program made up of engineers and flight analysis folks, and they look at everything, they help define those requirements, and then we go out and procure a vehicle from a commercial partner. In this case, it was the Atlas 541 for the Mars 2020 mission that was needed for performance, right? As you and I have talked over the last several days, Josh, one of the things that was important for us to look at was that performance, to be able to get Mars 2020 onto that transfer orbit into solar orbit to intercept Mars in 7 months. It's kind of analogous to a football game, right? With a quarterback trying to throw a pass downfield. You need a quarterback with a lot of performance who can get that ball down there where it needs to be, so the receiver can intercept that. In our case, 7 months later.
There you go. Yeah, it's the longest football pass ever. The Earth is the quarterback, the Atlas is the quarterback's arm, Perseverance is the football, and Mars is the receiver.
That's exactly right.
And what we also talked about is that technically you could launch to Mars at any time if you had a rocket that was powerful enough. But this is the launch period every 26 months or so, as we've talked about, that makes the most sense because you require the least amount of energy to get to Mars because it takes a lot to get there. Obviously, like the Atlas 541 is a workhorse.
Yeah, as Tori said, it's their Dominator. Right?
There you go.
I love that name for the Atlas 541. But we heard Jim Bridenstine, our NASA administrator, tell us that if we didn't make this launch period, we would be down for roughly 26 months.
It's
right?
Tough.
So the period started July 17th and goes to August 15th. Today, July 30th, was one of those launch opportunities that we had. We had a 2-hour window, and within that window, we had several opportunities.
25, actually.
Yeah.
25 opportunities.
And we launched at the beginning of the window on our first opportunity to get Mars 2020 going on its way. And that, that sounds like a lot, and it is. The flight analysis group, both at JPL, LSP, and ULA, did a lot of work to pick out those target sets and figure out where we needed to be. So they've done a great job, and we'll see how this mission continues.
So, Mick, tell us about the 2 burns required here, and we're actually coming up on the end of the first one. Ultimately, a lot of people probably, and myself included at some point, just like, why wouldn't you just keep firing the engines? Just fire all the way through and get to Mars in one shot.
So the first burn gets us into that park orbit we talked about. We've lifted off, we've left Earth, we've got
The host would like you.
Testing.
Can you hear us now?
Yes, we can hear you.
Ah, okay.
Yeah. So,
All right.
woohoo!
Yeah, that was exciting. We're on our way. So that was just.
I know.
We just saw through the.
Congratulations, first of all, to the Mastcam
volume
Z
up,
team and Mars 2020. It was awesome.
Yeah, so we just saw through the first manage and cutoff, and we've got a half an hour of coasting now. So
all right.
Spacecraft is in orbit around the Earth, a partial orbit around the Earth, and you saw the cruise stage at the tip of the Centaur there. So we'll coast for a half an hour. Then that main engine fires again, and that's the one that actually sends us out away from the Earth towards Mars, and it looks like that's like 7 or 8 minutes. And then at 57 minutes after launch, that's when the Centaur separates and the spacecraft is on its own, flying on its way to Mars.
So actually, some of the questions in the Q&A, they were asking about how long it's going to take for us to get to Mars. When are we going to arrive there?
Yeah, so we'll arrive there on February 18th at about 12:30 in the afternoon Pacific time, assuming that the second Centaur burn goes well.
Right. Yeah.
So, yeah, and so that's a Thursday. You guys busy that day?
I think I'm free.
Okay.
keep that date.
Yeah.
Hold the date.
Yeah.
Save the date.
So we've got like a half an hour where not much is happening, but I know that Meg and Justin or others are going to be monitoring just to make sure, and they'll break in if anything exciting happens with the launch vehicle, and yet you can still see in the NASA feed there what they're.
So we're back here in panel view mode, and actually, if Jim, you have a model of the Mastcam?
I do. We have some show and tell toys, so I can show and tell. A Mastcam Z. We have two Mastcam Z models, and I don't know if you can get a zoom in on this, Rick. I can't see our picture on the screen there, so don't know if you're seeing this or not. How's it looking? Okay. So this is one of the two Mastcam Z cameras, and they're up on the mast of Perseverance, and this is a model of one of the two. This is not the actual one. And you can see for scale, I say that it's about the size of a can of tennis balls, pretty close, right?
Yeah.
And so it's got 4 main parts. This part here is where the detector is. It's an imaging sensor, just like in your cell phone, except it's ruggedized, except it's higher fidelity, lower noise, all that kind of stuff. And electronics are in here that run it. And then this part right up here is the filter wheel, and in this model they've made it transparent so you can see the filters. So we spin filters in there, red, green, blue, little ultraviolet, little infrared, and take color pictures that way. And then this part here is the zoom. The zoom lens is in here, and when our website goes live, you'll be able to see a great computer animation of the zoom lens in action. And then there's a focus lens right here in this part. So these little cylinders here are little tiny motors. This one runs the filter wheel, this one runs the zoom, this one runs the focus. And this focus lens moves back and forth and gives us a good focus. And then there's a kind of a sunshade, scattered light shade in the front. So when you see the head of Perseverance, either in a computer animation or when the Watson instrument on the rover's arm takes a selfie of the rover, you'll see the two front light shades of the Mastcam Z. And the rest is kind of hidden underneath the hat on top of the rover, so you generally don't see this part. And that's so that's kind of our one part of the camera system is 2 cameras. There's an electronics box that's inside the rover. It's kept nice and warm, that provides the power, does the data processing. We transfer the data from the cameras into the electronics box. That box inside the rover then talks to the rover's computer to get us our data. And then the other part of it is calibration targets, and Kristen's going to talk about our calibration targets.
Yeah. So on Mars 2020, Mastcam Z, we have 2 calibration targets. So we've got the one that, if you're familiar with Mars missions, with Curiosity and Spirit and PanCam, or sorry, Spirit and Opportunity, you've seen this target before. There's the color chips around it, the rings around it, and this little stick, this little gnomon. And new for Mars 2020, we have a secondary cal target. And so this is bolted to a vertical face on the rover. And so this is useful. It has the vertical wall, the vertical chips that will stay dust free. And then we have the horizontal chips that'll obviously collect dust. But
Watch your mic. Talking to your mic.
Sorry. What these are useful for is, so we understand the chemistry of the color chips very well. And so when we're taking images, we take images of these regularly and we use them to calibrate we use them to calibrate images we take of the surface. And that helps us understand the chemistry of the rocks around us.
Yeah, so the basic principle is you bring something that you know what it looks like, right? And this has green and red and blue and the grayscale charts like a photographer would use in a photo shoot. And we know what it looks like. So when we get the pictures down, Kristen and her team are able to balance the colors and calibrate just right, we'll get it right. So that's a simple way to guarantee that we know that the sky is not green or whatever.
Right.
Yeah.
And it helps with when one of the purposes of calibrating images is so when you're taking images of different things at different times of day and you want to be able to directly compare them. And so the calibration process helps with that, or allows us to do that.
Yeah, and
so
these were actually built, this is a model that Kristen's holding. She couldn't hold flight hardware like this, of course. But these, the actual flight ones on the rover were built by our colleagues in Denmark at the University of Copenhagen, and a variety of vendors and machine shops, et cetera, there. So they've contributed those to NASA for the mission. So we're super excited and grateful to our colleagues in Denmark.
Yeah.
And I was wondering, Minnie, if you, maybe Ernest could say something about how the data gets here.
Yeah,
how does it get into this
that'd be
room?
great.
Yeah.
And then what do we do with it?
Sure. Sure. So, so we go through operations planning in our uplink team, which is actually Malin Space Science Systems staff. So they actually generate the commands for a day's worth of observations. Those get sent up to the rover. So all of those images are stored both, as Jim mentioned, inside our electronics box, and then versions of those are handed over to the compute element for downlink. And that downlink can happen through JPL's Deep Space Network. And that's either a direct communication from the rover to Earth when the geometries are compatible with that. Or we also use orbiters, the Mars Reconnaissance Orbiter, the Trace Gas Orbiter, to relay the information from the rover to that orbiting spacecraft and then forward it on to the Deep Space Network. When it reaches the Deep Space Network, it goes to JPL facility. They do some unpacketization of the protocols from that communication path, and then those data products are available to us to download here at ASU and then begin the data processing to turn those into the observations that our science team and eventually we'll make it out on our public website.
Great. Hey, by the way, the Mastcam Z team, your shirts are getting a lot of compliments here.
Hey, bro.
Hey, yeah. Hey, so there's a question from Michael Fitzgerald who asks, will the instrument be turned on during cruise for initial checkout?
Yes. Yes, we will have, actually, Justin, why don't you take that one?
Okay. It's funny, I was just thinking about, we should mention that, but in October, after assuming the vehicle gets into space properly and everything goes well, we're going to do what we call a cruise checkout, which is where we power on the cameras. And there are two cameras. Jim showed one there. I guess you can see the other one there. We power on both cameras, and we take basically what we call dark frames. So the cameras are all bundled up inside of the rover, and there's all this hardware around it. So it's pretty dark inside, so we call them dark frames. But even just taking a single picture in the dark, we can tell a lot about the camera and how it's functioning. And we call that the signal chain, which is basically the sensor all the way through the electronics, generating data and sending it back to Earth.
And we take a few of those dark frames and we compare them, and we do all kinds of analysis and basically do what we call a functional test or health check. And the only thing that we really see besides dark frame are cosmic rays, because we're out in space, so we occasionally see a little streak across the image detector. And that is kind of our first commissioning activity in the operations phase. We'll do a second cruise checkout in mid-January, and then after that, the next images that we get are going to be from the surface of Mars.
That's great. All right. Hey, so we're at about 5:15 a.m. at the current time, and maybe we have a lot of questions here, and maybe we'll do about 10 more minutes or so of questions.
You can't hear her.
Oh,
hang on one second.
I think it's on our
having
side.
trouble hearing you.
Oh, really?
No,
sorry.
You're good. Go ahead. Okay.
Okay. No, I was just going to say that maybe we'll do a few more questions here before we jump off this webinar. But I know there's a lot of questions from folks that are listening in at this point. I wanted to ask actually. So here's a question from Jose Iruraldo. He says, "Will the data received from Perseverance be available to ASU students in order to conduct undergraduate research?"
Oh yes. Oh, absolutely. And not just ASU students, like previous missions to Mars, we are going to be putting all of the images that come down from Mastcam Z and all the cameras on the rover will go out onto the internet in essentially real time as JPEGs. And anyone can make their own panoramas and mosaics and false color composites and play with them and interpret them, whatever, who wants to. We'll be doing the same kind of thing. We'll be taking the raw data and calibrating it using the CalTarget and other kinds of processes and stitching together mosaics. The downlink team will be doing that. And and then we are obligated to share that data after we do the calibration and verify that everything is performing properly. This is Alyssa's job. We put it out into what's called the planetary data system for the whole world to have access to. So yeah, there are opportunities for maybe Ernest, we've got undergraduates working with our team right now. So.
Because we're at a university, we actually for almost all of the missions have students in their different disciplines. So we have software programmers. We have computational mathematics, just the broad range, astrophysicists, students, broad range of backgrounds who are doing various tasks on the project and helping us data analysis, data archiving, software development, systems administration.
And Sammy, who's on our team, is a graduate student, and so she's doing some of her thesis research, not on Perseverance data, but with the Curiosity rover data. So yeah, lots of student opportunities.
That's what makes some of these missions so powerful and wonderful, is that you're training the next generation of scientists and explorers, and we do that certainly at ASU, but also the data is going to be available, of course, broadly across to a lot of folks. So there's a question from Jenna Robinson, and this could go to maybe we could go around the room and ask other members of the team here. What does the team hope that Mastcam Z will uncover about Mars?
Ooh, I'll go last.
Maybe. well, how about Alyssa? Alyssa, what do you hope? You're one of the, I guess, youngest team members or the newest team members. Alyssa, what do you hope that Mastcam Z is going to find out about Mars?
I would really love to see a stromatolite sample in the cache.
Wow.
I'm sure a lot, yeah.
That is very specific.
And what about Corinne?
Corinne's laptop restarted, so
okay.
Corinne will join us momentarily, hopefully.
Maybe Samantha?
Yeah, there's a few different exciting minerals that form really only in liquid water that would be interesting to find.
Mm-hmm. What about Kristen? Kristen, what do you hope that Perseverance and specifically Mastcam Z, what do you hope will uncover about Mars from these?
I'm not really hoping that it'll uncover anything specific. I like rocks. so seeing rocks, images of rocks and other planets in place, like I'm excited to see these images.
Yeah. All right. And Ernest, what's your hope?
Oh, my hope. Well, like Kristen, my background's actually in hard rock geology, so I'm looking forward to seeing some, volcanics or maybe some, from Mastcam, we've actually identified a lot of meteorites on the surface of Mars, seeing some more of those in a different locale. Those will be interesting, and like the Mars exploration rovers, something like the blueberry, something that geologically we haven't encountered yet on the Martian surface. I'm looking forward to that. Oh, wow, that's different and new kind of observation.
Did Justin want to add anything? Justin Mackey?
Sure. So I take a more general approach, like a little like Kristen. My background is in physics and remote sensing, but to really cut it to the most basic case, I'm an explorer at heart, and I think Jim sort of feels the same way. We're all kind of explorers, and I really just look forward to seeing the new worlds that we uncover. And I see a lot of people's screen backgrounds showing these amazing vistas on the surface of another world. Not me, I couldn't figure out how to set that up, but so you see a room behind me, but we're really lucky to participate in these missions, especially with the universities like ASU, where we all get to witness for the first time in the history of the world, that we get to land on the surface of another planet and discover new places and new vistas. And so I just really look forward to that aspect of it. It's so exciting, and it's really just exciting that we're on the brink of doing another mission here. And that's sort of my philosophy on that one.
All right. Hey, actually, you know what? Vince Cerf is here. He's the VP and Chief Internet Evangelist for Google, and he's asking, when will sample retrieval be scheduled? Jim, did you want to answer that?
Yeah, gosh, I wish I had an actual answer. I mean, there's an evolving plan, right, that NASA is basically pitching to Congress and the administration and all stakeholders involved, that would, where Perseverance is the first part of this process. Our job after we land is to collect a really exciting, compelling, scientifically rich set of samples, and to convince the world that we have to bring them back, that they have to come back because they've got so much interesting information. We need the world's best laboratories to dive into them. And so, assuming we do our part, there will be a set of samples, and we don't know how we'll leave them there. We could leave them one at a time as we drive along. We could put them in little depots, 5 or 10 at a time here, 5 or 10 at a time there. The system that's been designed by our JPL engineering friends is flexible to any of those kinds of strategies. And I'm actually pretty glad that they're letting the tactical reality on the ground when we get there drive how we decide to do this. So we'll make some decisions. They'll be the right decisions at the right time. We don't know what they are, but the system is flexible, and there will be these samples. And then, in theory, the plan is in about 2026, a lander and a rover will be launched to Mars, and there may be European involvement. The Europeans are being talked with about providing the rover for that, something called a fetch rover. And that mission, that lander, takes the rover and also a small rocket on it that is a Mars ascent vehicle. And that lander, rover, and MAV go to Jezero Crater, somewhere near where Perseverance is. Maybe the same ellipse, who knows? Lands, the fetch rover comes off the lander and goes and does its job, which is to fetch the samples, right? Fetches the samples, brings them back to the lander, loads them into a canister, a soccer ball sized canister that's on the MAV, and maybe we'll bring 20, 30, 40. If we can fill 40, we'll fill 40, right? The system is flexible, but we want a great diversity of samples, the volcanics, the sediments, the soils. We want atmospheric samples, et cetera, and load them into that sample container. The MAV then launches off the surface, and waiting for it is an orbiter. And again, this is a negotiation with NASA, the Europeans, potentially others. That orbiter will probably also launch in or around 26. It's in Mars orbit then, and its job is to look for the sample canister that the MAV is going to put into orbit, capture it, bring it into a part of the spacecraft that is then launched back to the Earth. And then a couple of years later, that capsule descends into the desert in Utah, like the Genesis or Stardust capsules did previously for previous NASA missions. And that could be as early as 2031, if everything works perfectly, if everything gets funded, if all the technology development, all the international agreements, all that work, that could be just about a decade after we land. So the thing I'm interested in seeing is we're going to experience Jezero and Mars through these robotic eyes, through these digital cameras, through the avatar called Perseverance, right? And we're all going to experience that. We're going to build spectacular panoramas in this room and share them with the world. And then maybe 10 years later, we can actually see Mars with our own eyes.
I know.
Minnie, you will write a proposal, Minnie, to get some of that sample here and work on it in the amazing laboratories here at ASU with our colleagues here in CC and on campus. And I want to see Mars with my own eyes. Not that I don't trust the calibration, but I just want to see it with my own eyes. I don't know if I may be too old to make it there myself. Who knows? Maybe Elon Musk will give me a ride, but just to go from experiencing it virtually to experiencing it real, that's what this whole decade-long Mars sample return mission offers to us.
Yeah, so actually a related question is, what is the lifetime of the Perseverance rover mission itself, the prime mission, and then how long could it last on the surface of Mars?
Sure, but Justin, you want to take that one?
Sure. So the nominal mission is 1 Mars year, and so that's about 687, if we get that right, 687 Earth days.
Yep.
And so it's been qualified for that, and then typically as part of the qualification program that we do on the hardware, we show that it can actually not only last the nominal length of a Mars year, but maybe two times that, or maybe even 3 times that in some cases. So our hope is that it'll last more than a year, but everything is designed. The warranty is good for 1 Mars year, so to speak. And some of the missions, as many of you probably know, go on for much longer than the nominal length, like the Mars Exploration Rover missions, which Jim and I worked on, were designed to last 90 Mars days, and they went on to last, gosh, many years. In fact, I think the Opportunity rover, Jim, you remind me, I think it's
14 and a half.
Yeah, 14
and a half years.
Okay.
Yeah.
Yeah,
Spirit
over 10 years. So.
Yeah.
Wow.
So so we're hopeful they'll last longer than one Mars year, but 1 Mars year is the design lifetime.
Yeah. So basically, I mean, even after all of the sample tubes are actually filled up with sample and you've dropped off the cache, the rover could actually last well beyond that and continue exploring. So that's super, super exciting.
Yep.
Wow. So I think we're actually getting close to about 5:30 a.m. our time, and I just want to get some sort of last thoughts before we wrap up here. If we can just go to each one of our team members that are on here and maybe say a few words about what are you going to be doing for between now and when the rover lands there. What kinds of things are you doing, and are you? I'm sure you're excited about what's going to be coming next, but just a few words from each of you. That would be great. So maybe let's start with Kristen.
So from now until landing, the project is putting together lots of ORTs, so which are operations readiness tests and thread tests. So now's the time. Now we begin in earnest, really testing the ground systems that have been designed and put in place for processing the data that we're going to get to Mars. So now we really ramp up. If we thought we were busy before, like it's gonna get busier. I'm excited.
Practice.
Yeah, practice.
Yep.
Okay, Ernest.
Well, yeah, as Kristen said, this is really where the rubber meets the road. We've been working very hard leading up to this point. We're going to be working even harder. There's these ORTs and thread tests, and then internal tests to make sure everything's ready. So when that first observation is acquired and downlinked, where we can process it and start doing some science with it.
That's great. What about Alyssa? What are you going to be doing between now and landing?
I'll be working on the archive and making sure that we have everything we need to have it set up so that all of everything can be publicly available for students and people alike. So definitely very busy, lots of training. I'm looking forward to it.
Yeah, super important. And Samantha?
Yeah, so I'll probably be participating in some of the practice tests. I'll also be helping plan some of the locations that we will hopefully get some of these cached or stored samples to return. So it'll be pretty excited. We'll have a good game plan for when we land.
Awesome. Hey, I wonder if Corinne is back.
Corinne back?
No, it doesn't seem like it.
Maybe not.
Don't think so.
Okay.
No.
So maybe give the opportunity here to Justin to tell us what he's going to be working on.
Well, I'm going to be very busy like all of us. I'm processing a lot of the calibration data that Jim talked about that we looked at, that we took a bunch of data from the cameras before we launched. So that's one of the things on my plate. I'm also helping to coordinate a lot of the testing of all the instruments, especially Mastcam Z, but all the instruments on the rover. And so we're preparing these operational readiness tests. Ernest kind of mentioned that. And those are tests where we all basically simulate operations. And so everyone has their role, and we flow data into the system, and we do what are called polling, where we ask how did the data look, and then people generate commands for the cameras, and then they send them, we send them to a simulator, and we do that over and over and over. As Jim said, practice, getting ready for landing day, basically. And so we're going to be very busy doing that. It's kind of fun and exciting too. It's a lot of work, but it gets us ready for the real thing in February.
Yeah, and of course during this time, Jim's going to be hanging out in his Hawaiian shirt, drinking Mai Tais, correct?
Pretty much.
Yeah. Jim just says, "Make it so," and then we all jump into action.
Or did you want to say a few words, Jim, before?
Well, look, you can tell we have a fun team, and and this is just a fraction of it. There's about 100 people or so who are directly involved in day-to-day operations. Well, first fabrication, and then testing and calibration, and now operations of Mastcam Z. When our public website goes live anytime now, we've got a special page there all about the team, and everybody's got a little picture and a bio, and you can find out more about what we're all doing, including a lot of students who are involved in the mission from many organizations around the world. And so it is just a pleasure to work with these folks, and they're super dedicated. And it ranges from, seasoned old graybeards like me and Justin, who've done a whole bunch of this kind of work with a variety of missions, to brand new people who don't have that experience, including a lot of students just getting started. What a great thing it's going to be for their career. So it is kind of like being an orchestra conductor. You see this guy up there with a stick, and it's like, he's not really doing anything. He's just waving a stick. And I kind of feel like that guy sometimes, but doing a lot of behind the scenes work, Justin and I and others on the project leadership. You know, we got to deal with budgets and reviews and all that kind of stuff that we have to do. But I am really looking forward to diving into the trenches and working with especially the downlink team here at ASU to put these beautiful image products together and share them with the world.
Well, that's wonderful. And we're looking forward to all of the wonderful data that Mastcam Z, of course, is going to be bringing us, and of course, you know, all of the data that we're going to be getting from Perseverance, and ultimately the samples that we're going to be getting back from this mission. So yay! Yes. So thanks for joining us this morning. I want to thank all of our audience members who were here, who asked lots of great questions. You know, we tried to get to as many as we could. We had a limited amount of time for that, but we really appreciate your sending in those questions. So I want to thank you all for joining us this morning. I want to thank each of our panelists who are here this morning as well, who contributed to this great discussion and helped you know, enjoy the launch as we watched it live. So I hope everybody enjoyed this this webinar and panel discussion, and please visit cc.asu.edu/events for more public events at the School of Earth and Space Exploration this semester. I want to thank the awesome staff who made it possible for us to do this webinar, and include Kim. Yes. Yay! Yeah. Kim Baptista. Yeah, Kim Baptista, Karen Valentine, Rick Alling, and Meg Hufford. So thank you so much for all of your help, and we look forward to seeing everybody next time. See you, everyone.
Thanks, Minnie.
Thank you, everybody.
Bye.
Thanks. Bye-bye.